I'm going to maybe. It depends on how much time it takes to explain to JS. And I'm probably gonna have to take a bunch of pauses, and it's probably gonna take a long time. So, because there's a lot of things to explain. And I'm gonna talk about the parts that I don't like. I'm trying to create a project, and I have to understand how 3JS works. And I think I'm going to try to simplify it some parts, and that's why I'm studying the source code. So I'm going to explain this thing first, which is the graphics pipeline, because it's going to make it easier to explain everything else. So I explained this on another video, so I'm not going to go too in depth into this, but there were some parts that I didn't explain very well, I think, last time that I did this, a video explaining this. So I'm going to explain it again. So basically the way that it works is that you send an array of floats. That's going to be the data. And then you have to create two different files that have two different codes. Obviously, one is going to be the vertex shader, the other one is the fragment shader. And then inside of this code, you're going to declare a bunch of variables. And the data you send is going to be, you're going to replace the variables inside of these two shaders with the data you send here. And that's pretty much the pipeline. So start with the data, pass to the vertex, and then eventually gets to the fragment shader. And then whatever framework you're using after that is going to receive the points that you draw, that you send, and is going to put those points on the screen. So the vertex is the points, the location of the points, and the fragment is the color that they are going to have. So basically everything is on a triangle, is either a point or a line or a triangle. And the fragment is the specification of how the colors of the triangle are going to be. And in order to do that, it's going to depend on the framework. But if you're using 3JS, it's going to be WebGL. And if you're using C++, it's going to be OpenGL. So there's a bunch of OpenGL functions that you call. You have to create something that is called a program. A program is just connecting this vertex shader code and the fragment shader code, and you put them like on another, let's say, class. And then from that program, you use the program to tell OpenGL when to get the data that you set up and all these buffers here. So basically the way that the buffers work is based on, it's just a place in memory, and you send the data through the buffers. You structure the data. You have to specify based on OpenGL functions how you're going to structure the data. So this is basically the functions that you have to do. This is a very simple example on C++. So I'm just gonna briefly look into this here. So basically, I have this function here that creates the shader. This is the code it comes from here, I think. My shader source. And so it basically creates the shader, which is probably an object, and the fragment shader based on this code here, which is very simple code. And then it specifies this array of floats here. And this is the function that I want to talk about, is this one. So this is one of the functions. There are other ones to specify, I think, how to get the data. But pretty much what this function does is allows you to specify how OpenGL should read the array of floats in order to replace it with the variables you specify on the vertex code or the fragment code. So for example, here, first argument would be 0. So this means that the location of the variable where the variable is inside of the shader code, which in this case would be this variable here, location 0. Then the other argument is the size of the data, like how many items in the array you're sending to replace this specific variable. In this case, it's 3 because of vector3 variable. Then here you have to specify how many indexes you have to go to the right of the array in order to get the start of the next variable that is going to replace the data. So it's like you're telling OpenGL how to read the data you're sending so that it replaces the variables inside of the shader code to draw this stuff on the screen. Then after all these setups here, you call this function that binds the buffer, and then there's other types of buffers, these types here. And the differences between them, I'm not going to talk about it, but the VAO pretty much stores the VBO is the most simple one, and is this part here, and the VAO allows you to store the state, so you don't have to constantly specify how OpenGL should get the data you're sending. So it's pretty much storing the state. And then later on, inside of the rendering cycle, we're gonna call this, which is gonna get the program, which is the linking of the fragment and vertex shader codes, and is gonna use that program to get the data from the buffer and draw on the screen. And that's pretty much the basics of how it works. And then if you're gonna do this just one time, then it's very simple, because obviously you can do that just on that file. But let's say you have multiple different shaders you want to use, and you have multiple different types of data you want to send. Then it becomes very annoying to just do it everything like this, because imagine like for each one, you're going to have a different array you're going to send, and you're going to have different specifications of how OpenGL or WebGL should read the array to get the data. So it makes more sense to create classes to manage the data that you're going to send. Manage the data pretty much. And the way you communicate with the framework. So I'm going to start with Three.js, then later on I'll talk about Threepp, which is the C++ version of Three.js. But basically the way that Three.js does that, it has a geometry class, a buffer geometry class, and it has a material class. So the material is related to stuff that is going to manage the fragment shader, the variables on the fragment shader, and the geometry is the class that manages the way that the data is going to be structured to create the geometries. And then these two are going to create a program, but the main class that they are put into, let's say, is the mesh. So the mesh is the main thing that interfaces with the scene. So like hopefully this is understandable so far. So I draw a bunch of other stuff here. This one makes it easier to understand. The base class is the object 3D. That's all the other classes inherit from this one, the main ones. Then you have the scene, which is another class that inherits. It's just gonna manage which objects are supposed to be rendered. Then you have this other one, which is the mesh that I just talked about. And the way that the mesh is going to work is you're going to pass these other classes here, which is the material class and the buffer geometry class, as with dependency injection, which means that inside of the constructor, when you're initializing the class, you are going to pass as arguments the buffer geometry and material. So there's like you're creating these classes separately, and all the other classes are just the classes that create the geometries are just further specifications of how the buffer geometry is going to work. So the sphere, so all these other geometries here inherit from buffer geometry, and they just have additional stuff to tell it how to structure the data to create the geometry. But all of them eventually become inherit from buffer geometry. And it's the same thing with the material. So this is on the vertex side, and this is on the fragment side. And then after you create these classes separately, what you have to do is just create a mesh based on these classes. So I have the example here. I think I'm going to close this thing, which is on the Three.js project that I was doing. So basically, that's how it works. You create the mesh. You select one of these meshes, and then this one is going to inherit from the material. And then you create the sphere, which inherits from the buffer geometry. And then you pass these two as arguments to the mesh. So the mesh is the main one, and the mesh inherits from object 3D. And object 3D is the main class that has the functions that allow you to manipulate the matrices to do the updates and stuff like that with the objects on the scene. So the main thing to understand is that the final stuff that you're going to pass to create the scenes and visualizations is going to be meshes into the scene, which is another object 3D, but there is a higher class, it inherits from object 3D. I think I opened here somewhere. Yes, this is the scene class, inherits from object 3D. And the way that you're going to do that is just by calling the add function. And what the add function does is a function from the object 3D class. And it's just going to put that mesh as a child of the scene. So that's pretty much the way that I was setting up. So you create the meshes separately based on this way here. Then eventually you create the scene, and then you call the add function on the scene to add the meshes as children of the scene. So that's pretty much it, the beginning. So I think that's this is enough here. So this one I did based on the Threepp because I was studying Threepp, but it's pretty much the same way that it's going to work on 3JS. So the way that it works, they initialize a canvas here, and the main thing, the main class that is used to render everything is the renderer, which is the WebGL renderer in case of 3JS. And this class here is gonna have a bunch, is gonna initialize the context, which is gonna initialize a bunch of different classes that is gonna use to manage how everything is gonna be rendered. So as you initialize the class, which is the renderer, is gonna initialize a bunch of these classes here. And these classes are gonna be used throughout the rendering cycle to update everything and to manage everything. So the main class that's, so this stuff not related, have this scene. And this stuff is just from Threepp. Yeah, but the main stuff is this one. So you're passing the scene. So before you create this class, you create the scene, you add the meshes, which I just explained, to the scene. They're going to be children of the scene. And then you pass as arguments to the render. You call render with the scene and the camera, which is another class. I don't remember if the camera is, I don't know if I have it open here, if it's an object 3D, but I assume it is. So a camera is just a matrix on the visualization. And then because we multiply everything by the camera, then the visualization is going to be viewed through the lens of the camera. Because it's all matrix multiplications, what's happening, to determine what's going to be shown. I think I closed the camera class, so I'm not going to, maybe I can find here very quickly. Yeah, camera. So you have different, the one that I was using is perspective camera, which is this perspective projection, which is just kind of like I forgot the name of the thing, but it creates the illusion of 3D pretty much. And this one inherits from the camera, so it's the same pattern as the buffer geometry and the material. You create a base class that is going to serve as a template, and then you create other types based on that, which is going to be other classes that inherit from the template that is going to specialize how that thing is going to work. But yeah, let's see if the camera. So the camera is an object 3D as well. So everything works based on the object 3D, and object 3D is going to have the calculations of how to update stuff. This one has some extra functions that are going to be responsible for converting different coordinates from the world coordinate to the local coordinate of the object and vice versa to update the objects in relationship to the camera. And this is one thing that 3JS does that is different than some examples that I've seen, that they update the model and view matrices, which is the relationship between the object on the scene and the camera. They update outside of the shader. And the examples that I've seen, the simple examples that I've seen, they usually update inside of the shader code. But I'm going to explain more about this once it gets to that point. There's a lot of stuff here. So basically, the main thing that happens is you call this render, and then you pass the camera in the scene. Let me go to the function. And then what I did was just go over the function, go over the execution. I think it's this dot render. So it's basically this function here, the main function that is going to run. And this is going to be the one that is responsible for rendering everything. But there are several different things that are kind of confusing here. So I'm not really sure what's the best way to explain it. But basically here, these functions here are updating the camera and the scene, which are the main objects for the visualization. And one of the things that is confusing is the current list rendered. So this is the thing that is going to be responsible for deciding what thing is going to be rendered. But I think I'm going to explain this later. So the other thing that I have to explain is basically the relationship between the shaders. So just like I explained there in the beginning, what you're gonna have is because the framework has to be useful for any use case, you're gonna have situations where you have several different shaders and several different vertex shader and fragment shaders, and then several different programs. So what you need to do is just create another class, which is called the programs, and that class is gonna store multiple different versions of different programs that you create. So you have a programs class that is gonna contain a list. So I think I'm gonna show that now, and then I'll go back to this thing here. These classes are initialized in the beginning of this the render class. So this class actually, and that's kind of the part that I didn't like about this, is because it's very confusing to understand how the programs relate to each other. But this class is initialized as you initialize the WebGL renderer. And this contains a list, which is the programs, and is gonna push programs to this list here in the rendering cycle. And programs are another class. So it's one of these functions here. Is this function here? So somewhere along the rendering cycle, it's gonna call this function, and then it's gonna see that it doesn't have the program here. And then it's gonna create a program based on this class here. So this is the class that is responsible for creating the shaders. So actually they have shader code on somewhere else on the project. And what this class does is just puts a bunch of extra stuff here based on parameters, which I'm gonna explain as I go over the rendering cycle. And then you gets whatever shader is related to the current thing that you wanna render, which is gonna be based on the material type. The way that they select the shaders is based on what kind of material you are using. Because the material class is gonna have the type attributes, and based on that type is gonna have on this class here, it has a map or an object. So this is the object. So these are the default shaders. So based on the material type, it's gonna select what kind of shader it is, and is based on another file. So inside of this function here, calls this function somewhere along the rendering cycle. Then based on the material type, it selects, which is this object, it selects the shader ID. And then based on the shader ID, it gets the vertex from this shader lib, which is another file, which is this one. And this file, so it's basically the object, and then based on the material type, it's gonna grab one of these. And these ones are on other file, which is the shader chunk. And the way that they structure the shader is because once the shader starts to get very complex, the code for the shader, what they do is just put a bunch of include statements inside of each shader, and then they separate the code for each shader on several different other shaders. And then they have some codes that has the logic to parse the string that is equivalent for the shader, and then based on that string is gonna find whatever other shaders that shader is made up of, and then at the end it's gonna connect everything and it's just gonna send the whole code. So I believe that, yeah, so this file is gonna get from this one, and this one is the one that has all the different types of shader, which are stored here on the renderer shaders shader chunk. So the main shaders are just a connection of all of these other shaders here. So one of the ones that I was using here is the mesh basic. So it's pretty much like this. So it just has these includes here, and then each one of these is going to be one of the chunks from this one. So I think the main ones are stored on the shader lib, and then based on the main ones, it finds all the other ones based on this. And the code that does that is some code that they have, and I think the code is from the WebGL programs. Is one of these functions here, if I remember correctly. So probably this function that specifies all this. Maybe it's on the other class. There is a function that specifies a bunch of, it's probably this one. Yeah, this, so it is on this class here. This is actually a function, but when it calls this function, it runs this stuff here, and then based on this other functions here, so this is the stuff that they're gonna put in the beginning of the shader based on some control flow, and these parameters are like specifications that you have. This is another part that is confusing, so I'm gonna have to go over the rendering cycle to explain this, which I really don't like, and that's the thing that I'm trying to change because I thought that was very confusing. So I didn't like that much the way that they handled the shader structure and manipulation. But basically, yeah. So it has these strings here, which are going to be the prefix stuff we're going to put. Then it's going to call these functions, which are resolve include, and it's going to send the string, which is the string that was done based on the beginning there of the map that it uses, because this comes from this is another function actually. So it's very confusing because of these parameters here, but pretty much the main code is the one that I was showing there. So it's gonna find that shader based on the shader chunk file, which is gonna be this code here pretty much. So the other function that I was showing is just gonna put some extra code in the beginning of this code here. So that's what the prefix vertex and prefix fragments do on the other function. They just put some code, like it's like they're adding code here, a bunch of code, based on whatever parameters you initialize the class with. So it has the prefix here, and then this is going to be from that file that I just showed, and it's going to call this function, and then this function is going to be the one that finds how either this one or some other one after this one is going to find all the other codes from the other shaders, and then it's going to put everything together into one massive shader. And then based on this, don't have time to follow now. Sorry. Oh, okay, thanks. So it gets the prefix, the shader, then joins everything. And this is going to be the final shader, which is just the massive string, and then it calls this function to actually generate the object that communicate with WebGL, and attaches the two shaders and then creates the program here. So this is the class that is responsible for creating the program, and then each mesh is going to have one of these. And then somewhere along the rendering cycle is going to call one of the functions from this class, and then it's going to append just the function that I just showed there. I think it's acquire program. This function here, it calls this function, then it sees that it doesn't have the shader on the array. Then if it doesn't, it just creates one, and then it passes there. But let me go back to the rendering thing. So let me follow this again. So this is another part that is confusing. I'm probably gonna go back to the other one, but I think it's better to just continue the execution here, and then once it gets time, I explain the thing again. But basically, the way that this works, I still don't understand very well how it works, but they pretty much create other class. So this render list here is gonna be a class that they initialize in the beginning, and they create this class to map, to create a map inside of this class for each scene and each render list. So I'm going to show the class there. And then based on this current list, this is the one that is going to contain, it's going to contain on an array all the objects that are currently supposed to be rendered in the scene. So it's going to start off with the main one, which is the scene, which is passed to the render function. This function here. So this class here is this one, I think. This one. So basically initializes this in the beginning of the renderer class. And what it does is just stores the scene to a list, which is another class, which is this class here, which comes from the same file. And this is it's not a class, it's a function, but it returns a bunch of these functions here. So it pretty much works as an API. So it's returning an object with the functions. And this is the class that is going to contain what kind of objects is going to render. So it's very confusing because of that, the way that they initialize everything and the way everything is connected. But pretty much, it's going to store the objects on these render items here and on these other lists here. So what it's doing here is just getting those render items based on the scene here. And then is actually this one. And then this is going to be the current list. Then these functions are just like, they don't matter that much. The one that matters is this one. Obviously they do, but it's not for what I'm trying to explain. So in this function, they're going to pass the scene, the camera, and this was the one that was kind of confused, that I kind of missed the way that it works. So pretty much this function here has, the first object that it passes is the camera, which is a 3D object. As I explained in the beginning, it inherits from object 3D, the class. And then based on this here, there's going to be this control flow that is going to determine what kind of object it is. And if it is a mesh or something like that, then it's going to append, it's going to push to the current render list. So it's just going to extract from the object. So I'm not 100% sure, but I think what is going to happen in practice is that you're going to have, the scene is going to have a bunch of objects, a bunch of meshes on its as its children. And then this function passes the scene to this, the scene is passed to this function. And then here it calls the function recursively based on the children. So what it's going to do is just access each mesh that is a child of the scene and call the function recursively with the mesh. And then once it calls the function recursively with the mesh, it's going to hit this control flow here. And then it's going to extract the information from the mesh. So which geometry is using, which is going to be the geometry class from the mesh. This one. So it's going to extract this geometry. And this is going to, it's not always going to be the buffer geometry. It's going to depend on the geometry you created the mesh from. So in the other case, would be the sphere geometry, for example, because I'm creating the mesh based on the sphere geometry. And whatever material you create the mesh with as well. So just extracting these classes based on the mesh object. It's very confusing to understand what is going on there. And then once it does that, then finally it's going to push that to the current render list. And the final item here that it pushes on this thing here is not going to be, like, it's not the object 3D. It's going to be this other object that this function creates. And so it's going to push. It's calling this function here, push. And yeah, it's going to be on the render item. So it's going to create, based on those things that it extracts from the mesh, it calls this function here. And then it creates this other object here. And this is the object that is going to render on the next function that I'm going to show. So it's just storing the main stuff from the mesh on this object here. And then it's pushing that to the render item, which is this list. That's going to contain all the objects. So pretty much the render items is just containing all the information based on this other object here, containing all the information from the meshes. So this is what this function does. So I stopped here. So it puts everything on the render items. Then it's going to call this other function here, render scene with the current list, which is the one that I just showed here. Is this API here, the function. So it calls this other function, which is the render scene. Then based on this, it's going to check to see, so it's going to access the values of this thing here, which are these values here. So these are the lists of what kind of object it has. And these objects here are based on whether or not they have, if the material has some property. So the material is the material class you're going to initialize the mesh with, which is, in my case, mesh basic material. So it's this class here. And they're going to check to see if it has a type or not, if it has an attribute or not. Then based on that, this function here, so if it has this transmission or transparent, it's going to become different types of items here. In my case, it would be opaque because the mesh basic doesn't have anything. So it just sends to the opaque list, which is going to be this one here eventually. Then it's going to check to see if there are objects, and then it calls this one, and this is the main one that is going to render. So it's passing all the items, which are the objects that I just explained. Then this one is gonna loop over the list, which is the render items list. It's gonna loop over this list here. And then it extracts the information. So at the end of it, this is gonna be the object, which is the class, the mesh class. In the case of rendering a mesh, I think usually it's gonna be the mesh. The geometry is gonna be the geometry of the mesh, and the material is gonna be the material of the mesh. And then it's gonna call this other function here to render the stuff on the screen. So what this function does, pretty much. So here, I'm not 100% sure, but because I don't remember the nuances of it very well, but the way that it works is that in order to create the view, you have to multiply different matrices, and each matrix stores the information of the state of an object or of the world, in the entire world coordinates, of where the world position is at. So I have the matrix world, which stores the state of the current object, and then you have this camera world, matrix world inverse, which I believe does the translation between the world coordinates to camera coordinates. So what this is doing is just multiplying the local coordinates of the current object with the coordinates of the camera, and then is storing that on this model view matrix. And then what it's going to do eventually, I think I'm not going to be able to explain this because it's kind of complicated, but eventually there is a variable inside of the final shader that they use. Probably I can show that. So in this function here, so as it is creating this thing here, as I just explained, like this is going to be the prefix that they put on the shader code. So regardless of which kind of shader you select, they're going to insert these variables here on the shader, on the code. So this model view matrix is going to be basically that other matrix, because they're going to call other functions in order to call WebGL functions that are going to structure the buffer, as I explained at the beginning, to pass the data from the buffer based on the classes, the way that they are managing the classes, or which class you chose. So basically the geometry you chose. Based on the geometry you chose and the way that the geometry you chose shapes the data, is gonna call a certain shader. This actually doesn't depend on the geometry of the thing, but it's pretty much, you understand what I'm saying. It's just passing, it's gonna eventually pass the value that it calculates there for this matrix, which is just basically the multiplication of the coordinates of the local object with the camera into the shader code. So it's just gonna replace based on several WebGL functions that determine how to pass the data. But I'm not really sure if I'm going to be able to explain that because it's very confusing. So, and there's also the other stuff that I have to explain, the other C++ code. Then these are functions. Just I didn't get into them. I assume that they're gonna allow you to set up events or something like that. It should happen before it renders and after. But then this is the main one that connects with the buffers. So it calculates, it updates the model view matrix from the object, and just view multiplied by model and the normal matrix, and then it calls this function here. And this is the main one that is gonna interact with the other classes in order to figure out what is the program that is being used by this object, which is the mesh, and all the other attributes from the program that are going to allow it to call a bunch of functions that are going to replace the variables with the data, depending on what kind of classes it's using to create the visualization. So I think that this is the main one that gets, and this is what I didn't like that much, because it gets very confusing. But basically here, there is some specification. This draw start and draw end, I think, is how many points you're going to read from the buffer. So it's a specification. And these variables here, if I remember correctly, they're stored somewhere in the class, at the geometry class here. So this is going to be the geometry from the mesh, and the material is the material that the mesh is using. The object is the current mesh that is going to be rendered. So it accesses these attributes based on the classes you have. Then this binding state is related to how it's gonna set up the buffers. Then here there's some control flow to see if the object is a mesh, if it's a line or whatever, depending on which one is gonna set a different render mode. This one also initializes this class in the beginning, if I remember correctly, and it's just a buffer. So I assume that it's a WebGL buffer, and it is, like I said in the beginning, it works as a bridge between the data and the actual shader, what's going to happen inside of the shader. So you code the shader and you give the data, and then you specify to WebGL through these buffers how to extract the data and replace the variables inside of the shader with that data. And you do that with the buffers. So if I remember correctly, so is this one? It initializes these classes in the beginning there. Yeah, here. So they're going to be these classes here, and they're going to have the states or functionality to manipulate the buffers and to draw this stuff. I think this is the one that is used to draw. So based on this control flow here determines what kind of functions WebGL. The gel here is the WebGL context being used, I think. And then it calls the function based on these parameters here. This is the final thing that actually draws this stuff based on all the other stuff that happened before. Well, let me go back to render. So wanna go into this one. So now I have to think about, because I remember there is some stuff that is confusing. I think I remember. So yeah, this is the part that is confusing. So in the beginning, as it is initializing this WebGL renderer class, it initializes these properties here, and this is gonna be this class here, WebGL properties. So it's very similar to the pattern of this one. It's just creating a map between some information between the object, which I don't remember very well if it's an object 3D or if it's gonna be a mesh, but it creates this map, and then based on this, it gets the, I don't remember if it's the material. Based on the material, so this is the material from the mesh, current mesh. Based on all the other stuff that happened, it passed the material. So you can imagine that is replacing this stuff here with whatever mesh you used in the beginning to create the mesh. So in my example would be this class here. Since I created my final mesh with the mesh basic material, the final material is going to be this class here, which is going to be this one. And then based on this thing that initialized in the beginning, is going to get the parameters for this mesh or this material. And then it's going to store this on this variable here. But in the beginning, I think it's not going to have the parameters. So I think it's this one. So because no, this is some control flow to see if anything changed during renderers based on this thing here. So this thing, if I remember correctly, it stores what parameters the current material has, which the parameters are going to be the variables that are used to specify how the fragment code variables are going to be replaced with data based on the class. But this part was very confusing, and it's still, I think it's on the, trying to remember. Because the tough thing here, I figure out, but I forgot now. To understand what this class is. Because I want to understand what this is. This one I remember that this program cache here is I think that's one of these other classes. I think it's the WebGL programs. So basically, the way that they initialize the parameters for each material is going to be inside of one of these functions. And that's the part that I really didn't like. I think it's on this one. So it passes the material. Then it finds the shader based on the ID that starts at the beginning here, based on the material type, which comes from the class. Then if it doesn't have shader ID, it gets from the material. I think it's not, it's acquire this one. So here. So these are the parameters that are going to be used. So it initializes everything on inside of this function here, the parameters, and then returns this. But there, I did remember. Let's see if I can remember the other one, because I did figure out, but now I forgot. The acquiring program is just creating the programs. So it basically initializes each program that it's going to use inside of this function, and then initializes the parameters inside of the other function, which I really don't like, because it makes it very confusing to understand what's going on. But this function only runs if it doesn't have the program, or if the programs need to change. So it's like initializing the parameters here, and these parameters are used at some points to build. I know that they are important, but there's some other part here that was confusing that depends on the parameters. So it's getting the program based on the material properties. I think that this has should be. Maybe this is the object that I just saw there on the other class. No. So maybe I'll skip over this. I should have wrote it down, but I'm not sure if it's worth it to spend time now trying to remember how it works. Basically, this one I remember because it's just a class there. So the way that initialize in the beginning is just gonna call the other functions from this class here, and then inside of these functions it initializes the parameters for the first place in the first time, and the on acquire program is gonna initialize the shader for the first time with the WebGL program, which is the class that manages the shaders. Hey, what's up? But this one I don't remember very well. So it gets based on the material, but I don't remember. I think it's just gonna be an object in the beginning, like that empty object. So it's receiving the material here, and is storing the material based on this map. So I think the beginning is just gonna be this undefined. It's gonna be undefined, and then it's gonna be an empty object. So it's mapping the material with this empty object here, and then it returns the empty object. I think that's what happens in the beginning. So this is just an empty object, I think. That wouldn't make sense because the function here. Hmm. Whatever. I'm just gonna continue, because otherwise it might take a long time for me to remember how it works. But I think it's on this class, is on this function here that it gets the program for the first time. Uh, it's that program. And then based on this, it's gonna get this value here, and then it's gonna update the values inside of the shader based on which program it is, and the values from the camera and the other stuff. Maybe if I look into the other functions, I will remember. But I think that's pretty much it for except this thing that I forgot. The rest I talked about. No, it's probably better to go into the shader. But I explained the shader, the way that the shaders work already. The This is the final thing, I think. Let me go back to the other function to see if I remember. Oh, there's the other thing, the binding states that I want to show. But it just has a bunch of functions that are gonna structure the buffers. So the main thing that I don't like one thing that I think that I'm not 100% sure, but the scenes seems to be a little bit unnecessary. And because you can do everything on the renderer class instead of creating another scene object, and then you can just inherit the renderer from object 3D, but I'm not really sure. Like maybe it doesn't matter that much. But one of the main things that I didn't like is that they only create this class in the beginning of the WebGL renderer, and then the way that they add the programs, which is the other classes here that are actually gonna build the program based on build and select the one that selects is this one, which the default shader, but this one builds the prefix and adds some stuff to the code, to the shader code, and then it calls these functions to actually create a program. The way that they add this one to this one is through one of these functions here, and I think this is kind of confusing. So the way that I was thinking about doing, instead of doing like this, is like you could just create a simple map and then map some property that I don't know very well from the class. From one of these classes, like it could be from the mesh, for example. You get some attribute on the mesh that specifies what kind of mesh it is, and then you create a map that takes that attribute from the mesh and maps that to the program that is related to. And I think that would be a lot more effective. So you wouldn't even need to create this class here. Or either this one or this one, like you would merge the two, and then you would just store the states based on that. So one of the main reasons why it's possible that they did it like this is because of these parameters here. And this is another thing that I don't like, because the first time that you initialize the parameters, like it doesn't happen on the renderer functions there. It doesn't happen here. It happens on, which is the thing that I kind of forgot now. But there's not much you can do. But in one of these functions, they're gonna call. Maybe you can look into this function again. I think it's either this one or the acquire. I think it's this one. This is the function that they create the parameters in the first place. And as far as I understand, this has a bunch of different variables here that are going to capture the values of each class of the mesh basic material, and in my case, and the sphere geometry, for example. So they're just getting these values here. So the best way to think about it is that these classes, the material classes, are used to manipulate and handle all the data that is going to be related to the fragment code. And the geometry classes are used to manipulate and handle all the data that is related to the vertex code. And the final mesh one is the one that is directly connected to the scene, which is the class that connects them both. So it would be analogous to the program, for example. So the mesh is analogous to the program, geometry to the vertex, and material to the fragment. And then based on these parameters here inside of this class here. It's just extracting all the values of those classes, and then it's gonna use these parameters at some point to pass these values to the shader code that it's gonna select based on the other class or based on this class to replace them and then to pass the data through the buffers, which is gonna be done with another class. That is other classes that are initialized there in the beginning of the WebGL renderer. So this is just structuring all the data, the parameters here. So I think I'm gonna search for this one because maybe this is gonna help me remember the stuff that I forgot. I think, but this only happens one time, I think. So it's not really what I was thinking about. It only happens if the program change. This is not gonna run the first iteration, I think, or first time that you render stuff. So it has to be done based on this thing here. And this one comes from the other stuff. Comes from the properties here, initialized in the beginning. So I think I'm not gonna remember this class here. So it's passing the material. Maybe it is an empty object. This is gonna be undefined in the beginning because there isn't anything. I think it's just an empty object, but then how it doesn't make sense. Two more properties. Maybe I missed something. Maybe if I go back to the if I go back to execution, maybe it changed at some point. It stored something, but I don't think that's the case because that's not how I remember figuring out. So if it takes too long, I'm just gonna go to the explain ThreeppP. So ThreeppP is just a ported version of 3JS to C++. So it's exactly the same way, the structure, everything, but it's all C++ instead of JavaScript. Which might take a long time as well to explain. I'm already getting tired. So there isn't anything here. Just gonna call this, and call this. I really wanted to remember. I'm not gonna be able to remember. I'm not gonna be able to remember, so I'm just gonna continue. Probably gonna study this again to understand. So maybe start there somewhere. What I can go is just go back to the initialization of the class, but then like it might take a long time, so I think I'm just gonna not gonna go into this, which kind of sucks, but yeah, whatever. But the other thing, I think the last thing that I wanna explain on this one is after it selects, after it gets the program for the current mesh. I don't remember, I think it's on the other one because this is the one that's is called. So the main one that renders is this one, and this one is gonna call this other stuff to. After it gets the program here, it's gonna call other things that communicate with the buffers. Now I don't remember if it's on this one or the other one that has the binding states thing. Both the state and so I roughly understand how it works. I don't understand very well, but from what I understand, they create this renders list that I explained, which is the thing that it's gonna all the objects that have to be rendered, and then they create another thing which is a stack, which I think is the state. So they store the state of each thing and they put everything into a stack, and then based on that they render everything. But the state I didn't look too much into because I also didn't like that much, and the stuff that I'm gonna do is probably gonna be simpler, so I'm not gonna need it. So I think I'm not gonna even going look into. Well, this is like the way that they handle it is this thing here. The way that they handle the the shader structure, the program structure, and the shader structure, I didn't like very much. And the way that they do this final part here of deciding how to render everything. But I might change my mind because I didn't go too much into that of how exactly the variables and the data are being replaced in the buffers. So I think this class sets up initializing the beginning of the render class. Here. And then this is the one that has similar functions that I showed on the OpenGL version, if I remember correctly. The bind buffer here, the only difference is that this C++ uses OpenGL and here is WebGL, which is different frameworks to communicate with the GPU. But it's pretty much the same thing. So based on the attributes, and I think this is like this stuff here is going to be based on the material and the geometry of the mesh. So just getting the values of each class and then calling these functions to set up these other functions that are going to structure how what data has to be sent and how WebGL should read the data to replace the variables instead of the shaders. So this is connected with the other functions as well, the program functions, because you have to know what program is being run. But like I showed there at the beginning or before, it already has the program. It passes the program for the setup function there. And then this one also has, yeah. So this is the function there that I was showing in the beginning there. Like this is the index, which is the location of the variable and the size of the variable. So if it's a three-dimensional point, it's going to be a vector 3. Usually it's a vector 4 because of homogeneous coordinates. I'm going to put a link on the description to the other video that I did. Explain more on the coordinates because it's quite confusing as well. The stride is how much you go to the next to get the next variable. But I think I'm gonna, so it's probably enough. I'm going to go over the 3PP one. I'm not gonna go spend a bunch of time, I think. This is another buffer that it uses. So this is the main one that it uses to do the draw call, which is the stuff that is actually gonna use the buffers, the data that is inside of the buffers, to draw this stuff on the screen. So it's this one, it should initialize at the beginning here, this class here. Just the one that I showed, and it calls either this function or this, depending on what kind of mesh it is. And I think the start and count holds our variables inside of the sphere, or inside of the geometry, or the buffer geometry. The draw range here, just using these variables to determine how to draw. So I think now I'm going to show the 3PP version. It's a shame that I forgot the other stuff. Maybe I didn't even, maybe I got confused and I thought I knew, but I didn't. The parameters thing here. Whatever. So basically 3PP is exactly the same thing, but everything is on C++, obviously. I think I'm just gonna go briefly over, but it's pretty much the exact same thing. The only thing that changes is the types and stuff like that. So maybe it's not worth it to spend a bunch of time. But I think I'm gonna just follow the execution here. The one thing that I've realized here is that they use a lot of shared pointers. So whenever they have a bunch of vectors and then they use shared pointers to pass stuff on vectors. which makes me think that that's probably a good pattern to do. So this is the render function, is the same thing as 3JS. Camera and scene. Then you update the matrix, have the render states. And for my stuff that I'm trying to do, I think that these are the main things that I want to try to change. Is the rendering function. I think I'm gonna simplify this a lot, and managing the shaders and the program. I think that can be simplified or like reorganized so that is not so confusing. So here, same thing. I'm probably not gonna spend too much time on this, to be honest. So next stream that I do, I'm gonna do this other project here. So the thing that I did was just replace. I found the shader that I was using there based on the material and all the other stuff that I explained, and then I actually replace all the code into one single file. And then I'm gonna use this as a template to create other shaders. So I'm gonna remove a bunch of this code that I think is not necessary. And I'm just gonna try to simplify as much as possible. So I'm just gonna get the geometries and meshes and material that I was using, and then I'm gonna try to change the classes. So I'm just gonna get from TriplePP as much as I can, but then simplify all the classes and then maybe change some types and the way that they manage those parameters and how they are passing the data. But in order to do that, I'm gonna probably have to next stream spend a bunch of time to understand how exactly the data is being replaced. So maybe this is the last thing that I can show, is that obviously it already showed how they build the shader there. But you can see here, like in the beginning, I put these variables in the beginning. This is the prefix that they put. And then you can see that it's being used inside in the actual shader code, inside of the shader code, to calculate this stuff. So there's a bunch of things here that are there are a bunch of control flow statements, because obviously, because they created something generic, it's going to depend on the way that people set up the classes at the high level, the buffer geometry and the other stuff. So they have to put a bunch of if-else conditions here inside of the shader code, which is all of these variables here are going to be replaced based on the other ones, the higher level abstraction based on the data that is being passed. But here, there is a lot of stuff that I don't understand here as well, and it seems that's kind of pointless, so I don't understand very well. But the this is the actually the fragment. So let me show the vertex first. The final thing that the vertex shader receives, or yeah, I think receives. So like this is the default variable from the vertex shader, and this is the variable that determines the position of the actual point you're sending, because you're sending point by point through the shader, so that it draws everything at the end. And the way that they do this calculation basically is based on this shader, which is the shader related to the mesh basic material, because the shader selection is based on the material only. The geometry doesn't matter, because all that geometry is just the structure of how the array of floats is going to be done, which is based on the control flow that you send to the buffer. It's going to determine how to structure that data. So the only thing that matters, the main difference, I guess, from one shader to the other is going to be the material. And so they base what shader is going to be used, what default shader is going to be used based on the material type. So this is the mesh basic one, and the way that they calculate the GL position is based on this calculation here. So this one is just because of the control flow that they do here, but they get this variable here. So it's just basically matrix multiplication. Let me see. I think this variable in the beginning is on the beginning there. I don't remember very well. This is basically the position. It's the same calculation that I was looking into some other. So this variable is one that depends on the prefix as well. So is structured there on the class that I showed. Because it's going to be the same thing on TripleP as it is on. I already looked into, and this is the same. But it's basically the insert based on this code here. Is on the prefix there, and I just copy paste there. Somewhere here has those variables. Yeah, I think it's these ones. Here. I just copy pasted this. So I assume that this is going to be the position of the model. So the calculation that it's doing is just, or of the data, let's say. Yeah. So the calculation that you do is the position of the data you want to send, which is either going to be, is going to be a vector because of homogeneous coordinates, but it's transformed is going to be the position, which is just the vector of 3 points, x, y, z directions of the actual data you're sending. Then they're going to multiply. Then the reason that why they only multiply by the model view matrix here because of the stuff that I explained there in the earlier, that this one encodes already the multiplication of the model matrix with the view matrix. And I think that the reason why they do it like that is because the object 3D class, and I think mainly object 3D class, has all the functionality to calculate to do the translation, rotation, or whatever you want. So I think that it makes sense to multiply on the high level and then already send the matrix already after the multiplication. So the model matrix is the one that holds the state for the object that you're trying to render, and the view is the matrix that holds the state for the camera. So they multiply both at the high level on the render scene or on the render loop there that I showed. Then they pass that value directly inside of the shader. Then they multiply by position, and then the other one that they multiply by is the projection matrix, which is another thing that I kind of didn't like because the projection matrix is initialized on the WebGL render class, if I remember correctly. At least on the, I think I didn't see on the 3JS, I saw on the 3PP, but it's probably the same. So the projection matrix is initialized on this class. It's this one. So they initialize here, which to me, it feels kind of weird, but I think I understand why they did it like this, because you can have multiple different cameras. So they store the state of the projection in the main render class. But the way that I'm thinking about doing is either removing the scene class and just doing everything on this one, or putting this projection matrix on the scene class. So basically this just stores the calculations. It's just a matrix that is gonna store calculations that create the illusion of 3D. So it's pretty much the same example that's, it's the same calculation that I showed on the last, on the stream that I did explain the graphics pipeline for OpenGL. And that's how they calculate the position here. So yeah, I think I'm gonna stop here. And I was thinking about going over the 3PP, but it's gonna be the same thing. The code is the same, it just changes. And probably next stream, I'm going to spend a bunch of time studying this more on the 3PP side, because I want to understand exactly how the data is patched to the buffer so I can change everything. So I'm probably already going to spend a bunch of time studying this next stream. So I think it's probably good to stop here. And also, I'm probably going to study this other part that I couldn't explain. That's kind of confusing. I think I'm going to study more here, see if I can remember how it works. And then if I do, maybe I'll do another video and then, or another stream, and then I'll link to this stream. I'll put the link in the description, but I'm not really sure if I'm going to be able to, or what I'm going to do after, because I'm already tired. So yeah, so see